Hello, we are researchers from Morph Lab, Imperial College London, and we present a realistic pain expression simulation using perception-based weighted action units. The pain expression is a direct and accurate way of informing others about one's discomfort. Facial expressions can be analyzed quantitatively using Ekman's facial action coding system, and the pain expression had been shown in numerous studies to be composed of at least 4 facial action units, being Action Unit 4, brow lowering, AU7, eyelids tightening, AU9, nose wrinkling, and AU10, upper lip raising. These action units had been shown to be present in multiple cultures, which suggests there is a degree of commonality of the pain expression across cultures. Fax-based computer graphics applications such as OpenFax and FaxHuman allow users to directly change the activation intensity of individual action units, commonly through a slider or an arbitrary value. However, no studies had been done to evaluate what action unit values should be used to accurately simulate these expressions. For example, the 4 images shown here can probably all simulate the medium pain expression, but which one should people actually use? We aim to find the answer by studying the pain expression specifically, which can be formulated as a combination of the 4 action units we presented earlier, multiplied by their perception coefficients. If we know the mean rated intensity of the images of pain expressions with non-action units and non-individual action unit coefficients, we can then use regression to determine the perception coefficients of those action units. We developed an online survey to get people's ratings on pain intensities of 81 images with different action unit coefficient combinations. These images were generated using MakeHuman FaxHuman plugin and a middle-aged Caucasian male model. The coefficients we used were 0, 0.5, and 1, and the 4 action units were the same as the ones mentioned previously. We received a total of 24 responses from people, and the rated pain intensity in 45 out of the 81 images was shown to be normally distributed using Shapiro-Wilk test. And the perception coefficients were calculated using those images as shown in the table below. From the table, we can see that the perception coefficients are not all equal, which suggests people value different activation units differently when determining the intensity of the pain expression by perception. And the coefficients of the lower face action units 9 and 10 are much greater than the upper face ones 4 and 7. This suggests lower face activation units are more indicative of the overall intensity of pain, which is consistent with previous findings. The 2 video clips down below shows the differences between an unweighted simulation and the perception-weighted simulation of pain expression increasing from 0 to maximum. More information about how facial expressions are simulated and rendered in medical training simulators can be found in our IEEE Access paper. We also applied this model to our Morph-face robot in an attempt to simulate patients of different genders and ethnicity using a morphable face with front projection. Our future study will be to find the dynamic perception coefficients of more pain expression activation units using Morph-face, and ultimately building a robotic patient that can realistically express different feelings through facial expressions, haptics, and other feedback modalities. Please also visit our department website to learn more about Dyson School of Design Engineering, and also the Morph Lab webpage to see our other research projects and publications. For more information about this particular project, please feel free to drop me an email at the link below. Thank you.